Hello! In this tutorial video, I'm going to give a brief overview of the Tau Commander tool. I will show you how you can use it to measure the performance of a simple C code as well as of a PyTorch application. Tau Commander is based on Tau, an open-source suite of tools for instrumenting codes, making performance measurements, and analyzing and visualizing performance data for high-performance computing systems. Tau can be used to answer many different kinds of questions about the performance of your applications. For example, Tau can be used to instrument the functions and loops in your application, to identify how much time is spent in each function and loop. Tau can use sampling to identify the contribution of individual statements within a function. It can collect hardware performance counter data to identify the counts of different types of instructions within a code region, or count things like cache misses at different levels of the cache hierarchy. It can monitor the allocation and deallocation of memory in your application in order to determine the memory consumption of code regions or identify the source of memory leaks. In multi-node applications, such as those using MPI, it can monitor the time spent in communications routines, such as MPI collectives, and it can be used to collect, analyze, and visualize data for scaling experiments, showing how the time spent in functions changes with input size and/or number of ranks. However, Tau is complicated software. It has many different dependencies and compile time options that change based on the libraries and features used by the application you are measuring. It has several different mechanisms for instrumenting applications, with a large set of runtime options. Tau Commander is designed to provide a simplified and consistent interface onto Tau, downloading dependencies for you, picking the right compile time options for your specific application and environment, and invoking Tau correctly for those options. Tau Commander provides a declarative approach to performance monitoring. With the declarative approach, you describe your application and what you want to measure about the application. Tau Commander then does the work of converting that into a concrete plan for instrumenting the application and collecting the required data. We'll now take a look at how to download and install Tau Commander and apply it to a simple test code. Tau Commander is available for download for several different architectures at taocommander.paratools.com. There are two different installer types available. Most users should download the web-based installer. This will download dependencies as they are needed by a given experiment requested in Tau Commander. For users of high-performance computing systems which do not have access to the public internet, all-in-one packages are provided which bundle the current versions of all required dependencies. To install Tau Commander, extract the archive you downloaded from taocommander.paratools.com and run make install in the resulting directory, providing a path to a writable location in which to install it. After this, add it to your path environment variable so that you can use the tau command. Here we see the results of running the make install command to install Tau Commander into your home directory. All actions performed within Tau Commander are performed through the tau command. These are used both for Tau Commander-specific options, such as initializing a project or showing the collected performance data, and for compiling and running your code, which is done by prepending tau to your compiler and launcher commands. Commands in Tau Commander are arranged hierarchically. Top-level commands indicate the type of object to be acted on, while subcommands indicate the action to perform. Performance experiments in Tau Commander are specified as a triple of three objects. These objects are the target, which indicates the computational environment in which the application will be run, the host architecture and OS, the compiler, vendor, and version, etc. The application, which indicates properties of the specific application for which you will make measurements. This includes which libraries it uses, such as MPI, OpenMP, CUDA, etc. And the measurement, which indicates what performance data is to be collected. For example, whether to collect a profile or a trace, whether to use source instrumentation or sampling, etc. These objects are collected together within a project. A given project can contain many different targets, applications, and measurements. An experiment specifies a particular target, application, and measurement, and the results of running an experiment are stored as trial objects. We'll now look at how to use sampling on a simple matrix multiplication test code that is included with Tau Commander. Sampling is the simplest way to collect performance data, as it does not require any modifications to your code. So long as an application is compiled with debug symbols enabled, sampling will be able to collect performance data by periodically interrupting the application and recording the program counter value. To begin, we initialize a new project. Running the tau initialize command, or tau init for short, creates a new project configuration within the current directory and creates a set of default experiments for commonly used configurations. The included makefile in the example will compile the code, prepending tau before the invocation of the GCC compiler. In the case of sampling, Tau Commander does not have to do anything special during compilation. Because the default sampling experiment is selected in Tau Commander, it simply calls the underlying compiler without performing any additional steps. Then, to run the code, we prepend the invocation of the application with tau. Because we are sampling, Tau Commander does have to do something special at this stage. Here we see that Tau Commander sets a series of environment variables in order to configure Tau, and then launches the application through the Tau exec script. After the application finishes running, we can run tau show to launch a graphical visualizer for the performance data. Since there's only one node and one thread in this application, we see only a bar for node 0 here. Right-clicking a node will show a menu to view detailed data about that particular node. Let's go back to the Tau Commander installation I showed earlier. I'll change into the installation directory and add the bin directory to my path environment variable. This makes the tau command available. Next, let's try compiling the example code without Tau Commander. I change into the examples/mm directory, and I then compile the application with GCC, and then I run the application. The application runs a matrix multiply benchmark and prints done when it is done. Next, we will initialize a new project in this directory by running the tau init command. This will generate a new project with the default configurations for a serial application. Now let's repeat that, but this time instrumenting the code using Tau Commander. I build the application in exactly the same way, except that I use tau GCC instead of GCC. Then I run the application in the same way, except that I use tau matmult instead of just matmult. I can then run tau show to show the performance data collected. This shows the summary view of each of the nodes. By clicking on the node 0 label, I bring up a detail view showing the time spent in each code region for this application. Alternately, I can select to view the performance data with pprof to get a text summary. Next, we'll use source instrumentation on the same application. We'll change the active experiment from the sampling experiment to profile, which performs automatic source instrumentation. We use the tau select command to change to a different experiment. Running tau select profile changes from sampling to profiling with source instrumentation. We compile with tau GCC again. This time, however, rather than running just the compiler, Tau Commander substitutes the tau.cc.sh compiler wrapper script, which modifies the source code, adding instrumentation before compiling. We run the application as we did before, too, with tau matmult. This time, because the application has already been instrumented at compile time, nothing further is needed here, so Tau Commander simply runs the instrumented application. And, as before, we run tau show to see the results. Now let's try running it. I can run tau dashboard, or tau dash for short, to see the available measurements. One of these is profile. By running tau select profile, I can select it. I can then compile and run the application as before. Running tau show then shows the graphical view of the performance data. Clicking the node gives the detail view. and pprof can show a text-based summary. Finally, let's look at how we can profile deep learning codes. We've recently added support for profiling of TensorFlow and PyTorch applications to Tau Commander. Here we need additional support beyond what is available in the default project, so we will need to provide some additional arguments to Tau init. We will specify the -- Python interpreter argument to give the name or path to the version of Python that we're using, the -- Python argument to indicate that the application uses Python, and the -- pthread argument to indicate that the application is multi-threaded. Since Python is not a compiled language, we don't need to do anything special before running the code. We simply prepend tau before Python when running the application. If we use the sample measurement, Tau Commander will collect both sampling data and data from the Python runtime, whereas if we use the profile measurement, Tau Commander will collect data from the Python runtime only. Here, we are in a directory containing the quick start example that comes with PyTorch. We initialize the project specifying the Python interpreter and requesting Python profiling and pthread support. Next, we activate the profile experiment. First, we'll try running the application without Tau Commander. Running the application with Tau Commander then requires only running the same command, but prepending Tau. Running Tau show then shows the collected performance data. Selecting a thread shows the detail view for that thread.